Hello everyone, this is Nazeer from the Faculty of Civil Engineering Technology. We're going to go and try to solve. We are going to go and solve a system of linear equation that's listed right here, 3 of them. And when we look at this, we could see that x, y, and z, and the constant on the other side, for each one of them, you have to have it in those orders before you go and get your matrix. We're going to end up with 2 matrices from these, or matrices from these. We're going to have one for this side, which is matrix A, and this one will become matrix C, right? You only use the coefficient, not the variable. You only use the coefficient. When I go and pull the coefficient out of there, it'll be 1, 4, and minus 1. Right there, 1, 3, and 1. 1, 3, and 1. And likewise for the last row. On this side, it just stays the same. Matrix C just stays the same. Okay? Now, I'm going to go through finding the determinant for a 3 by 3. So, we might not use that determinant, but we're going to do it anyhow and get that out of the way. So, let's go and find the determinant of matrix A. So, this is the one, not matrix C, but matrix A, which is a 3 by 3. Right? And when I lay that out, this is what it becomes. I just repeat that, and also the first and second column, I have repeated them right there. Okay. The reason why I want to do this is because I need a full diagonal, 3 numbers, and when I repeat these 2, I will get those 3 numbers, right? Going this way in red is the principal diagonal, going that way is called the off diagonal, or the secondary diagonal. When we look at this, we are looking for the sum of the product of each one of these diagonals. The sum of the product. So when we look at this, when we go and get the product of this, you could see it becomes 3. 4 times 1 times 2 will give you 8, and minus 1 times minus 1 will be minus 1 times 6 will give you minus 6. So we have the product in this direction. Let's go for the off diagonal now, and we are looking at 6 minus 6, and we have 6, and right here we just have 4. So we have to go for the sum of these things now. When we look at this, we are taking away the sum of the off diagonal from the sum of the principal diagonal, right? The principal diagonal, 3 plus 8 minus 6, and that's what's there. We're going to put our minus sign in there, and we're going to take away the off diagonal, the sum of the off diagonal. Minus 6 plus 6 will give you 0, plus 4 will give you 4. So when we look at this, we have 2 right there, plus 3 is 5, minus 4 will give you plus 1. So that is the determinant of A, right? That's how you find the determinant of A. Okay, let's go and find the inverse using the Gauss-Jordon method of finding the inverse. Now, I have matrix A and its identity matrix right beside there, and I color-coded this so that we could follow through fairly easily, although it's not easy. These are very complicated, very easy to make mistakes type of problem. When we look at this, we have our identity matrix. If you remember, the identity matrix has in the principal diagonal, it has all 1s. Everything else, all the other elements are 0. And this is matrix A. The idea is to change matrix A into the identity matrix, and then the identity matrix becomes the inverse, right? So that's the idea of this. When we look at this, we are going to use line operation to actually change these guys into those guys, and then this part of it, the identity matrix, becomes the inverse. Okay, so that's what we are intending to do here. When we look at this, the first thing that I'm going to say is that when we look at the first position, position 1, 1, row 1, column 1, right? We see that it matches up already, and that's what we want. We always want a 1 in the row when we are looking at changing them. So we don't have to change row 1 at all. we have to change this to 0 to match that, and this to 0 to match this. So those are the two that we are going to go and change. When we look at the next step that I have written down here, I left row 1 as is because, again, these match up very well. You don't have to change that. We're going by column first, right? We're going to go down by column and change them in that fashion. Okay, so now what I'm going to do to row 2 to make that a 0 to match that, I am going to take row 2 and minus row 1. So if I take this and minus that, I will get a 0 in that position, right? And I have to do it to the entire row. I have to do it to the entire row. So when we look at this, we are looking at row 2 minus row 1. I will get 0 there. I have row 2 minus row 1. Row 2 minus row 1 will give me a minus, let's see here, row 2 minus row 1, minus 1. Right? And then we have row 2 minus row 1. This one, I'm going to just do this. We have row 2 is 1 minus a minus 1. This becomes positive, and you get a 2 in that position. Okay, and again we have row 2 minus row 1 will give you a minus 1. And then we have row 2 minus 0 does not change, and this one doesn't change either. And we're going to go and follow our instructions for row 3, right? And we're going to do the same thing. We're going to take row 3 minus 2 of row 1. Row 3 minus 2 of row 1. So when we look at this, row 3 minus 2 of that will give you 0 right there. And then we have row 3 minus 8 will give you minus 2. This minus 2 of that, and again I'm going to go and do this. We have row 3 minus 2 of minus 1. Right? You can see that the minus and the minus becomes a plus, both of them. So we have 2 plus 1 is 3. And then we do the same for this one. We have 0 minus 2 will give you minus 2. And then we have 0 minus 0 does not change. And we're looking at this minus that. 2 of that does not change. So when we look at this, I'm just going to look over this for a second here. And looks fairly okay. And that looks good. That looks good. Okay. Now again, I'm going to go and try and change this row. I've already changed the first row to what I want it to be. I'm going to go and look at this row to change it. When I look at that, again, I want a 1 in this column here somehow. If I have a 1, then I could go and subtract that from there and add that to there. I have to use a multiplication factor, of course, to get zeros in these positions. But I need also, this should be a positive 1. So I'm going to divide this whole row by minus 1. 0 does not change sign. 0 is always considered to be a positive number. This becomes a minus, this becomes a plus, this becomes a minus, and 0 stays the same. So I've divided everything. Now I have a plus 1 there. Okay. As I look at this, I am now going to go and basically move this up a little bit, and I'm going to go and map out what I'm going to do again. I know that this is 1 here, so that middle row will not change. I'm going to write that down, and that is supposed to be color coded as green, so I'm going to keep it as that. 0, 1, minus 2. I have my separator line, and I have 1, minus 1, and 0. Okay, and that is going to be blocked in. Okay. And this should be also black color. Okay, so we have that. What are we going to do to this guy here to make it a 0 is the question, really. So I'm going to take row 1 and subtract 4 of row 2. And then what am I going to do with this guy now? I am going to take row 3 and I'm going to add 2 of row 2. So that would be 2R2. Okay? And that's what my plan is, to make this into a 0 and that into a 0, right? To match these guys here, right? So let's go and deal with this. We have row 1 minus 4 of row 2. That doesn't change. 4, 0 doesn't change. That stays the same, and that's what we want. When we look at this point here, we have row 1 minus 4 of row 2, which makes this a 0. And we have minus 1 minus 4 of, let's do that one here. We have a minus 1 minus 4 of minus 2. You could see that these change to a plus. We have 8 minus 1 will give you 7. Okay, and then we're going to go and do the same thing here. We have row 1 minus 4 of row 2, which will give you minus 3. This minus 4 of that will give you plus 4. And then we're going to go this minus 4 of that, doesn't change anything right there. Okay. Now we are looking at this third row. Now we have to deal with that one, and let's go and deal with it. It says take row 3 plus 2 of row 2. Okay, so we have row 3 plus 2 of row 2. That doesn't change anything right there. This plus 2 of that will make this 0. This plus 2 of that, right, again 3 plus 2 plus minus 4 will give you a minus 1. And this plus 2 of this will give you a 0. And this plus 2 of that will give you a minus 2. And this plus 2 of that will give you that. Okay, so now when we look at this column here, it's changed over exactly to what we want over here. Well, over here, right? What we started with over here. Let me pull that down a little bit so you can see that. And it's exactly what we want. The second here is there. The first also matches up. So we are going to go and work on this guy now. Right? We're going to change that over. What we want is a 0, 0, and a positive 1. 0, 0, and a positive 1. So that's what we're going to work on now. When we go and look at this, we have to map this out. And the first thing I'm looking at here in this, I want a 1 somehow in here, and I have a minus 1. So I'm going to go and change that. I'm going to divide this whole row by minus 1. And I'm going to use a different color for that. So I'm going to use, and remember that the 0 stays the same. These guys change over. Okay. So now I've divided that whole row by, and this becomes a positive 1, right? It becomes a positive 1. It matches right here, positive 1. When we look at this, we're going to go and map out our plan again. I'm going to go and put and we know that the third row will stay the same, so I'm going to leave it as is. And we're going to use that third row to change this guy and this guy into zeros. Okay, so what is our plan? Okay, we are looking at 7. So we're going to take row 1, and we want to change that 7 into a 0, minus 7 of row 3. Right, and for row 2, we want to change that to 0. So we're going to take row 2, this is row 1, change the color here, row 2 plus 2R3. Okay, so that's the method that we're going to use to change this, and this is the last one that we're going to change, and then this side becomes the inverse. Right, and let's go and change this particular row here. We have our instructions are row 1 minus 7 of row 3. Row 3 is right there. That doesn't change anything. 7, when we look at this, 7 of this does not change that either. And when we look at this, minus 7 of this will give us 0. Okay, and this minus 7 of that does not change, and this minus 7 times 2 is 14. We are going to minus 14 will give you minus 10, and then we're looking at this minus 7 of that will give you, let's go and do this one here. We have 0, I'll do it here, 0 minus 7 of minus 1, and these becomes plus, so we have a plus 7 for that position. I'm changing my colors, and I'm going to go and use the green now. My instruction for the green is going to be row 2 plus 2 of row 3, right? Row 2, which happens to be 0, plus 2 of row 3, which will not change anything. This one here, row 2 plus 2 of row 3, will not change anything. But this guy here, row 2 plus, will make it a 0. And this one will not change anything. And minus 1 plus 2 of row 3 will be 4, will give you 3. And then the last one that I have to do here is 0 plus 2 of 1, so it'll give you minus 2. Okay. Now when we examine this here in comparison to this there, we have exactly the same right in here. So that means that this side now is the inverse, right? That is the inverse. Okay, let's go and find the actual x, y, and z. Right, we remember that the formula, I'm going to write it over here because I'm running out of space in the bottom. Right, I'm running out of space in the bottom here. I'm going to write this in here. we know that x is equal to really x, y, and z. Okay. Which is then equal to the inverse matrix, which is this guy here, minus 3, 1, and 0, and minus 10, 3, and 2, and 7, minus 2, and minus 1. And we're going to multiply that by matrix C, which we have dictated right at the beginning. And that particular matrix is 4, 7, 12. If you remember, multiplication of matrix, we have to, we should run the test. This is a 3 by 3, 3 rows by 3 columns. So we have a 3 by 3. And then we have 3 rows and 1 column. And that 3 by 1. Once these inside matches up, we could come out with a solution. The outside numbers tells us that we're going to have, for our answer anyhow, 3 rows, 1, 2, 3, and 1 column, and that will be our x, y, and z. So let's go and do that. Remember that multiplication of matrices is row times column. It'll give us our numbers. I am going to go and put these right here. When we look at this row times this column, minus 12, and this times that will give you minus 70. This times that, and this times that will give you 7 12s plus 84. And when we sum those, one here, we're looking at 14 there minus 12 will give you 2. Okay. When we look at this one, we're going to go and do the same thing. 1 times 4 give you 4. 3 times 7 will give you plus 21. And minus 2 times 12 minus 24. And that will give you right in there 3 minus 3 will give you 1. Right, so we'll get 1 right there. And we're going to do the last one. 0 times that will give you 0. Anything multiplied by 0 is 0. We have plus 14 and minus 12. And that will give us, when we sum that up, we'll get 2. So we have, for x, we have 2 right there. For y, we have 1. And our z, we have 2. If we were to take these and plug it into the original equation, we would find that they check.